Equivalent fractions. This is when two fractions look different but they equal the same. So this is what an equivalent fraction looks like. Here's our rectangle and we've shaded 1/2. So let's have a look at the same rectangle. We're going to cut that half into 2, which gives us 2/4. So on the next rectangle, what we're going to do is cut those quarters in half again, and as you can see, this is going to give us 4 lots of 8 that are shaded. Now if you were to put into a calculator 1 divided by 2, you would get the answer 0.5, and that's the same for all of these, and that proves they're equivalent. So the rule for equivalent fractions is whatever you do to the top, you do the same to the bottom. So if we've got 5, 6 and we're going to times that both by 2, that gives us 10 at the top and 12 at the bottom. So 10/12 is an equivalent fraction. So let's have 5, 6 again, and if we times the 5 by 8, gives us 40. We times the 6 by 8 gives us 48, and there's another equivalent fraction. So let's do 3/8. Remember, same at the top, same at the bottom. So 3 times 2 gives us 6, and 8 times 2, 16. There's our first equivalent fraction. So now we're going to times them both by 3. 3 times 3 is 9, and 8 times 3 is 24. So let's go a bit larger now. 3 times 100 gives us 300, and then 8 times 100 is 800. Now you may be asked to reduce an equivalent fraction, so we need a number that divides into the top and bottom. I'm pretty sure that's 15. So 45 divided by 15, that's 3, and 120 divided by 15, that's 8. So giving us 3/8 again. So what we're going to do now is find the missing number. So first thing we do is take 20 and divide it by 4, which gives us the answer of 5. So now we need to take 35, divide it by 5, which will then give us 7, so the answer being 4/7. Okay, and the next one, what we need to do is take 72 and divide it by 9, which is going to give us 8. So therefore we know that 64 needs to be divided by 8, giving us the answer 8/9. And on this one, we know 5 is going to 25 5 times, so we need to times the bottom number by 5, which is going to give us 375. Okay, and for the next one, if we look at the bottom, if we divide that by 10, of course it gives us 10. So we're going to times the top by 10, which gives us 60/100. So you may get asked if these are equivalent, so what we need to check for is the same at the top and the bottom. So 21 divided by 3 would give us 7, therefore we would need to take 30 divided by 7, which wouldn't give us 12. So this one isn't equivalent. Okay, and on to the next one. So if we had 4, 6 and 12 18s, let's take 12. We're going to divide it by 4, which is going to give us 3. So we're going to do the same at the bottom. 18 divided by 3 gives us 6. Brilliant. So this one is an equivalent fraction. Okay, so we'll do the same again. Take 10, divide it by 2, gives us 5. So we're going to take 15, we're going to do the same at the bottom as we did at the top, divide it by 5, which gives us 3. Excellent. So now we have 11/27, which equals 110/207. Now we know 11 is a prime number, but we know that 11 does go into 110 10 times. So we're going to take the bottom, 207, and divide it by 10, which doesn't give us the answer we want. It's not correct, so this is not equivalent.